Okay, so this is part 2 of our 1117, Thursday 1117 topic, and we are still working with proportional relationships. So, we'll continue on to question 5 in this part. Okay, so 4 gallons of gasoline cost $16.80. What is the price per gallon? Well, this should look fairly familiar. We did something pretty close to this earlier. So, if we're given how much gasoline was bought at a certain, a certain amount, total of $16.80 was paid for 4 gallons of gas. So, if that's the case, if we just want to find out what 1 gallon of gas costs, all we have to do is divide 1680 by 4. We got 4 gallons, we paid $16.80 for it, so certainly 1 gallon must cost something. So if we do the division, we find out that a gallon of gas costs $4.20. So that's pretty high. That may be for gas has come down quite a bit probably since this slide was made, so it may be for premium in California or something. So anyway, now we have a question, a different question. What is the price of gasoline in terms of gallons per dollar? Wow. So gallons per dollar. So we bought 4 gallons for $16.80. Now they want to know gallons per dollar. We typically don't think of gasoline in gallons per dollar, but we can certainly calculate gallons per dollar. So let's think about it, okay? We know that we pay what for 1 gallon? We paid $4.20, okay? So if we bought 1 gallon at $4.20, we know that a dollar's worth of gasoline is going to be less than 1 gallon. We can just think through it, pause for a minute if you need to think about that, but if we buy 1 gallon for $4, if we buy, or $4.20, so if we only spend $1, we know we're going to get less than a gallon. But we don't even need to think about it that way. We can just think about it, okay, here's our gallon. Here is how many dollars we paid for that gallon, so why don't we just divide this gallon up by the number of dollars that we paid, and that should give us how many gallons we get for $1. So let's see if that works. So if we divide 1 by $4.20 for 4.2, so 1 divided by 4.2, that is going to give us 0.238 and some other numbers that we will just leave off. So we're going to round 0.238. Now this is gallons for every dollar that we spend. So that's for every $1 we get 0.238 gallons. Another way to think about that is, if we know how to convert decimals to percentages, we got 23.8% of a gallon for $1. Okay? Now, we could have done this with the original information. Okay? If we bought 1 gallon for $4.20, well, we remember buying 4 gallons in our original scenario for $16.80. So if that was the information we were given and we didn't feel like doing any more calculation than that, we could have just done, okay, we paid $16.80, we bought 4 gallons, we paid $16.80. So if we divide those 4 gallons by the amount that we paid, we should come up with our same price for 1 gallon. So let's try it out. 4 divided by, and you can pause and try it on your own. I suggest that. Don't trust the teacher. The teacher can make mistakes just like anyone else. Probably even more so than most people. And indeed, when we do the division, 23 0.238 or 23.8%. So that is 0.238 gallons we can buy with $1. So, question C, do we need both rates in real life? Well, yes. I don't know if we need them, but they can certainly be useful in certain circumstances, if those circumstances happen to come up in real life as opposed to some sort of simulation we may be living in or something. So anyway, do we need both rates? Well, I can think of a scenario where you might want to know if all you knew was that someone or yourself or somebody paid $16.80 for 4 gallons of gas at a certain gas station, and you're driving around and you're looking for the cheapest gas. Well, they don't tell you how much for 4 gallons of gas on the sign at the gas station, right? They just tell you for 1 gallon. So we would need to figure out how much per 1 gallon, right? And we came up with $4.20. That way we can drive around and we can look at the gas stations and we can see, well, okay, it's $4.20 here, it's $3.60 here, I'm going to buy the cheaper gas, okay? That's simple enough. I think we all sort of ridden around with our parents looking for the best deal on gas at times. But what about how many gallons you can get for $1, or how much gas you can get for $1? Well, we need to know that. Okay, so the answer is, do we need both rates? Yes. The first one is for comparison. We'll say comparison shopping. But what about how much gas can you buy for $1? Why would you need that? Well, what about if in a couple of years you're going to turn 16? You may or may not have a car. You may be able to borrow a car. You may end up in a car driving, one way or another. So they do not run on air or water. They run on gas. So you will need to buy some gas. Well, let's say you're 16. You're probably not making that much money if you're making any money at all. So you have to scrounge up some money, and you scrounge up $10. That's what you got. You've got $10. Well, you need to know, maybe you want to take a trip. Maybe you need a certain amount of gas to get there. So you might need to know how much gas you can buy with that $10. So it's actually not equal. So yes, we could very well use that. Let's just take our 10. If we know that we can get 0.238 gallons for every $1, okay, we can just multiply that times our $10, and let's see what we come up with. I said 3 and wrote 8. That is 0.238. 8. Okay. So let's just do the multiplication. 0.238 times 10. We can get 2.38 gallons for that. So how far could we get on that? Well, let's just say that our car happens to get 20 miles per gallon. So if we needed to take a trip, and let's say it was 50 miles, can we get there? It's going to be pretty close. It's going to be pretty close, so let's try it out. If we have 2.38 gallons, and we're getting 20 miles per gallon, we can multiply 2.38 times 20, and that will let us go 47.6 miles. So you're going to be walking those last couple miles, evidently. So yes, you can certainly use that, unless you don't mind walking a little bit and leaving your car or someone else's car on the side of the road. So, on to question 6. Crystal's vase originally priced at $520. Crystal's vase originally priced at $520 are now on sale for, I think we've got some issues with that sentence, but this is math, so we won't worry about that for now, are now on sale for $416. What percentage is the discount? Okay, so couple of ways we can look at this. We can look at it sort of the common sense way, and that is we know the price dropped, and we can figure out the absolute amount that the price dropped by just subtracting 416 from 520. Okay, so 520 minus 416 means that now we have paid $104 less for the vase. So, if we paid $104 less, we want to know what part of our original price is this 104, because this is the price of the discount. This is the actual amount of the discount. Okay, now we know if we can make a fraction out of this somehow, we can convert it to a decimal, and we know we can convert a decimal to a percent. So, why don't we try 104 over 520? Okay, it's the parts over the whole. So if the whole is 520, we want to know what part of that is 104. So we can just do the division. So when we divide 104 by 520, we come up with 0.20. You can add your 0 if you like. It's really 0.2, 0.20, 0.20, any way you like it. Now, we know how to convert these two percents, right? We move our decimal 2 places to the right. So 20% is our discount. 20%. Okay, now, another more sort of formulaic way to do it, we can use our cross multiplication friend again. Now let's think about this. If we know the absolute amount, and we know the amount we paid before, this is actually going to be a lot more work to get the exact same thing, but we'll just go ahead and show cross multiplication again. So what we can do, if there's a certain percentage, okay, percent by definition means per 100, okay? Anytime you say per cent, well, how many cents are in a dollar? 100. How long is a century? 100 years, okay? So cent means 100, per cent just means per 100, okay? So there is, we know this rate, this 104 to 520, we can convert it to something per 100, okay? And we know that those ratios will be equal, okay? We made up the 400, or excuse me, we set the 100 because we want it in percent. We want to have a decimal. So now we can just cross multiply and solve for x. So all we do this way, 520, x equals 104 times 100. So let's go ahead and multiply. 104 times 100 is going to give us 10,400, 520. And you can pause and do this one yourself and just double check with my math, so just so we know we're all correct here. Now we have 520 times some decimal, some percent, some something equals 10,400. So to isolate our variable, I'm just going to write over this next question. We'll erase it in just a second. Divide both sides by 520. This is going to divide to 1, so 1 times x is going to be x. And 10,400 divided by 520 equals 20. Okay, so x equals 20. Put that right over here. So if x equals 20, we know that 20 over 100 is our new proportion, which we know is equal to x over 20, which we know is equal to 1 over 4, 104 over 520. So we can divide, if we want to, divide 20 by 100 to get a decimal, or we just know that anything out of 100 is by nature a percent, okay? But we'll divide, so we get 0.2, move our decimal 2 places, again, we're at 20%. So cross multiplication, a little bit more work than we needed to do on that, but I just wanted to show you that it still somewhat works. You just, in this case, you would solve for the x, then that would give you a new ratio of 20 over 100, which you would turn into a percent by way of decimal if you need to. So let's go on to the last one here. Kind of a long lesson. Again, the good thing about these is you can fast forward if you know this. You can rewind if you didn't get it. You can pause to think for a while or do some calculations. It's just anything you want to make out of it. So, William, he's out there eating at a cafe, and the cost of his meal is $28. Because of the service, he wants to leave a 20% tip. What is his total bill, including the tip? So we know part of his bill is going to be $28. So we're just going to write 28. I can leave off the zeros. Now, same thing as the one before. If we want to, we can just calculate what's 20% of 28, and we can add it back to the 28. So let's do that really quickly. If we want 20%, convert it to a decimal. We move the decimal place 2 places. We pretend there's a decimal here, first of all, which I guess there is. And we move it 2 places to the left, so we wind up with 0.20. 0.20 is 20%. That's either 0.2, 0.2, 0.20, however you like to write it. So 28 times 0.20, $5.60. So 20% of his bill is $5.60. Now, they're asking total bill, including tip. So we have to add this back to our original 28, and when we do, we come up with $33.60. So that's one way, but in my mind, an easier way, and you just kind of get into the habit, whenever you want to increase something by a percent, okay, and essentially that's what we're doing. We know we have to pay the bill, and we know that we're going to pay the tip. So really, we're just increasing the bill by 20%, right? Well, let's try our trick that we learned earlier, or maybe in part 1, I can't remember. Let's just add the 1 to what we converted 20% into 0.20. Well, we're just going to put a 1 in front of it. So that means that we will, first thing, we'll be multiplying 28 times 1, so that's going to leave our 28 in the mix here. It's going to leave it with us. But we not only multiplied it times 1, we multiplied it times 1.20, which is basically an extra 20%, okay? So if you do the math, 1.20 times 28, 33.6, or $33.60. So that's a brief introduction. Like I said, this is Future Thursday, so it's not like there's going to be a test over this tomorrow, but you are going to encounter it, and I promise you, you will see many, many, many of these problems in the future, near and far. So that's it for me. See you next time.